4b, we need to finish up 4-7 today, inverse trig, and maybe just a couple of you, despite the weekend, remember that I said something Friday about the unit circle coming back to haunt us, but not just the unit circle forwards, but maybe you remember I said you also need to know it backwards. We'll talk about that more today for sure, and practice. But we don't just need to finish 4-7 today, we're also doing 4-8 tomorrow. But 4-8 can be a really big, heavy section, which takes multiple days, or it could be a little light, we're just kind of seeing the main idea, which is what we're doing. So we're just going to take one day on 4-8, just the short, sweet version. It's right triangle application problems. You might be like, oh. There's something called bearing, where we come into like north, south, east, west, and how like, if you're doing navigation, you would find the North Star and measure from north, not measure awkwardly from east, like we always do when we're just talking about a normal graph. So we're going to do a quick little coverage of 4-8 with the shortened homework. That's going to be reflected on Google Classroom. I don't think it's on there yet. I think the full assignment is on there. I need to shorten it for you guys. And then we are having a Chapter 4B quest, like we had a Chapter 4A quest. So think with me. Today we're finishing 4-7. Tomorrow 4-8. Wednesday a review day, question day. Thursday the quest. Okay? That's the plan. Now hold on. Wait. What was in Chapter 4B? Bless you. It started at 4-5, which was, who are these guys? Sinusoidal waves, sines and cosines, how to graph. Then it went to, well, technically, these guys. Who are these? Cosecant and secant, and what do they do to their reciprocal sine cosines? Bounce, right? With vertical asymptotes, but they bounce. So basically, okay, it's still just knowing these and knowing how to bounce, right? And then we went to these. Cotangent, careful, tangent, right? Tangent, cotangent, who had vertical asymptotes. Things to study, vertical asymptotes. Then we're here, unit circle backwards, and then section 4.8, triangle problems. All right, cool kids, here we go. Quest on Thursday. 2 days, a review day, and then the quest. On Friday, we talked about how inverse trig says, give me your give me your ratios. Give me your ratios. Give me your, well, if it's sine, your opposites over hypotenuses. So katoa, sine, opposite over hypotenuse. Give me your opposites over hypotenuses, and I will give you. What happened when you plugged these into your calculator? Some of you were doing that, the second sines. Some of you were getting errors if you were plugging in ratios that were outside this domain, right? We talked about how sine goes between 1 and -1. So sine inverse you can only put in between 1 and -1. The x's and y's switch. But what do you get out? Who are these guys? Even though you were in a different mode on Friday. Angles. Some of you were getting out like 30s and 45s. I think Joe was the one putting in like the unit circle values. Others of you were getting out like actual angles. Different angles other than the unit circle. So you put in ratios, you get out angles. Quick reminder, whenever you do second sine, it's not the same thing as cosecant, but we've been doing this in our calculator correctly, right? How do you do cosecant? 1 divided by, right? Different. This, not this. This is inverse notation. So, sadly, the one thing we didn't get to do on Friday was actually go backwards. But I did have you guys on those graphs, right? Didn't we highlight some stuff saying we can only put in between 1 and -1 and we'll only get out in a calculator, and so we have to only give angles between pi over 2 and -pi over 2. So help me out, cool kids. I want you to go back to section 4.2. Table of contents, flip there quick. Section 4.2. What did we talk about in section 4.2? I think it starts with a U and ends with a knit circle. Double check though. Is that the right section? Is it 4.2? Okay. Okay. Unit circle. Can you find for me, whether you want to look at a cheater chart, whether you want to look at the unit circle, whether you want to think about triangles, can you find for me where sine, when sine is -1/2? Which one? If you're looking at the unit circle, we didn't do degrees on that, did we? We did radians. Where do you see, wait a minute, hold on, the unit circle, the x's and y's, is sine the x or is sine the y? Sine's the y. So look at when the y, for what angle is the y negative 1/2?
11 pi over 6.
11 pi over 6. If they were looking at the circle itself, Matthew, you're not wrong. But if they were looking at the circle itself, they would see 11 pi over 6. But pause, it's not the only place. Keep looking. Where's the other angle where the y is negative 1/2? It's the patty paper. Which one? Okay. So y, if Jason is completely correct, and if you were to look at your circle, the y's are going to be negative 1/2, which is what this is asking. When is sine negative 1/2? The circle says 7 pi over 6. The circle says 11 pi over 6. Why am I going to cross both of those out and put negative pi over 6, which, Matthew, does correspond with your negative 30? But we're doing radians. Go ahead, Matthew. Why?
Because the question has a negative and not positive.
Well, I wish that was it. That's a good problem solving. I'm really glad that led you to the right answer. But actually, that's not the reason why, and that might mess you up in other ones, like these ones. That logic will mess you up. So I'm really glad you got the right answer. He got it. He said negative 30, where the rest of you were just thinking through the unit circle. Negative pi over 6 is negative 30, depending on whether you're in radians or degrees. But what, having to do with the highlighting that we did on Friday, what on earth would make me put negative pi over 6 instead of 7 pi over 6 or 11 pi over 6? Why would I have to put that one? 7 pi over 6 is 1 and 1/6. Is that bigger than 1/2 pi?
Yes.
11 pi over 6 is 1 and 5/6. Is that bigger than 1/2 pi? Both of those are outside the range. So how else do I get to the fourth quadrant if I'm not allowed to go all the way around?
Go negative.
Go negative. So was your unit circle wrong? Is sine negative 1/2 at 7 pi over 6 and 11 pi over 6? Yes. But pause. Go to your calculator in degree mode. I want you to do second sine, sine inverse, second sine of negative 1/2 or negative 0.5. Hopefully most of you are in degree mode, because radians are weird decimals. We don't see the pi over 6s, pi over 3s, pi over 4s. Yeah, zoom, zoom. We're going to use it a couple times. Good idea. What do you guys get? Emma, what'd you get? Negative 30. Does that match up with negative pi over 6? Yeah. Negative 30 degrees, isn't that negative a little boop-a-doop, which is exactly what negative pi over 6 a boop-a-doop is? You could do radian and degree conversion if you want. But the calculator only gives you one answer. But that's true! I know 330 is. And that's true. I know 210 is. But what's not true? Neither one of those are answers from this inverse function, because the inverse function says, I can't give you every possible answer because there are infinitely many. I can only give you one answer in this range, and that's the one that we have to choose. So I want you guys to use similar logic. You still have, hopefully, your finger in your unit circle. Now you've been reminded, uh-oh, we have to choose the one angle our calculator would give us. You can check it with your calculator, but try without your calculator. Second sine of root 3 over 2. Think backwards. When is the y root 3 over 2? And how or which angle would I choose that would fit inside that interval? Tyler, here you go, kiddo. I think you're leaving now. Do you guys find it? Okay, what angle? Pi over 3. Why? Look at your unit circle. The y is root 3 over 2. And pi over 3 is totally fine. 1/3 is less than 1/2. First quadrant angles, I don't mind. Now, I want you to look at all the y's in the unit circle. Is there one where the y is 2? No. What's the highest the unit circle goes? 1. Why? Oh, because the waves only go up to 1. Huh. Well, then what are we supposed to... Okay, throw it in your calculator. Second sine of 2. Why is it going to be an error? We should have already known that. Why? Remember, unit circles, sine and cosine only between -1 and 1. That's always going to be an error. tricky. They were trying to trick you. Now, guys, in letter D, bye, Tyler. In letter D, is this going to work, first of all? 0.265, is that valid?
Yeah.
Yeah, it's in between 1 and -1. No stress. There's an answer, but is it unit circle?
No.
I mean, you could try. You could do 5 over, what is that, tenths, hundredths, thousandths? Maybe it's a hidden unit circle. But if I divide, I'll get, what, 53 over 500? That did not work out right. 200. Is 53 over 200 a special unit circle answer? No, we know what sign can be in the unit circle, right? What can sign be in the unit circle? One of 5 values. Go in order. No. Go in order. Nope. Nope. Thank you. If none of those are what is inside the sign inverse, guess what you're always going to be able to use? Yeah, go for it. Second sign, 0.265. Second sign, 0.265. That is a correct answer. 15.367. However, can anyone get me an equally correct answer? Because it didn't tell me what mode. Didn't tell me what mode, but I can tell those of you guys that said 15.367, you were in degree mode. Do you guys agree with Matthew? 0.268? Well, here's Dilio. I think the back of the book has both with an or, so you get to choose. Now, pause on the quest on Thursday. Do you think the multiple choice answers either have a degree mark or don't have a degree mark? You're going to have to make that call. Does that make sense? If all the answers to like an inverse trig have degree marks, you better be in degree mode. And it's not going to match up if you're in the other one. But if all the answers to an inverse trig don't have degree marks, must be radians. Jason.
Will there be questions where it will be mixed?
Not where the multiple choice answers will be mixed, but there will be different questions that need different modes.
Okay, yeah.
Does that make sense?
Yeah.
Yeah. But I won't put them all mixed into one. That's messy and disgusting. Now, guys, with inverse trig, actually, let's get to cosine and tangent, and then I'll go ahead and remind you guys of the cheater chart, which could when you're going backwards. Let's just go here for right now. Okay. So inverse sine. If you flip the sine curve, he goes on forever, but no, it fails as a function, so we can't do that. Same thing with cosine. If we flip the cosine wave, if I can actually flip him nicely. If we were to reflect the cosine wave, now this one's a little bit awkward. Hold on. That hits at pi over 2, which is a little bit more than 1. Only goes up to 1. Okay, something like that. If we were to flip the cosine wave, once again, he fails the vertical line test, just like sine did. So just like sine, we're going to have to cut this guy and only take a piece of him. And he's going to look like, let's see if I can get him good. Roughly like this. Inverse cosine. 1 over cosine. He's going to also go between -1 and 1, because just like sine, that's how high and how low the wave went. And so when you flip him across the y equals x line, that's how right and how left the wave will go. But what's different isn't the domain. What's different is cosine hits his like maximums and minimums and zeros at all different places than sine does. They kind of like are translations of each other. So therefore, cosine doesn't go between -pi over 2 to pi over 2. Cosine doesn't straddle the axis. Instead, cosine starts at 0 and goes to pi. Which might also make sense, because sine inverse goes between -pi over 2, or shoots out answers between -pi over 2 and pi over 2. Sine is negative down here and positive up here. But if we were to do cosine the same way, it's positive and positive. That doesn't work. I don't have negative answers, so I have to keep going. From 0 to pi over 2, I have to keep going to pi negative answer. So cosine is going to be a little different in that cosine you're looking in the first and second quadrants. for angles. First quadrant, the cosines are all positive, and second quadrant, the cosines are all negative. So that's where you're going to be looking. Tangent, super similar idea because tangent, remember, we just looked at, well, I think I held up a tangent sign just a little bit ago. Tangents look like this. They just repeat over and over and over again. Have vertical asymptotes at negative pi over 2 and pi over 2. So if you were to flip tangent, here's the cool thing about him. Flipping one tangent, he's actually totally fine. One tangent is totally fine. One tangent totally passes the vertical line test. But what's the problem? If you keep going, like you should, if you flipped the entire tangent graph, then it would start failing. But the nice thing is, for the inverse tangent, we just need to look at this one. We're going to ignore everybody else. But this one is going to have vertical asymptotes on the top and the bottom because normal tangent has vertical asymptotes on the right and the left. And the vertical asymptotes are going to be at pi over 2, at negative pi over 2. So this is the graph for my y equals cosine inverse of x, and my y equals tangent inverse of x. My domain, well, actually, cosine and sine were stuck. They were going to keep on bouncing, so only between 1 and negative 1. But check out your tangent guy. How right does he go? Yeah, and how left does he go? So actually, his domain, unlike the other two guys, I can plug in anything I want. Because he went forever high, forever low, so he's going to go forever right, forever left when I flip him. But his range is a little different. It's similar to sine inverse, but it can't equal negative pi over 2 or pi over 2 because tangent is undefined there. Those are the vertical asymptotes. So it's a lot like sine in that we're looking at the first and the fourth quadrants, but we can't go around to the fourth. We have to either go up in the first or down to the fourth with negative angles. So we're looking just the first and fourth quadrant. Tangent will be positive there and negative there. But now we get back to that age-old question of stink. Unit circle, still a thing, still important, still necessary? Yes and yes and yes. Yes and yes and yes. So really quickly, before we do some examples. Just like sine, cosine inverse is written with that little negative 1, but it can also be, do you guys remember those 3 letters that can come before that mean inverse? Did you write it down for sine? Arc, yeah, I heard it. It was in the back. So it could be arc cosine. And then y can equal tangent inverse or arctan. They mean the same thing. Don't be confused by the ARC. It just means inverse. No stress, no stress, no stress. You can type arc cosine arctangent where you couldn't type the cosine inverse and the tangent inverse if you didn't have like a superscript option. But quick reminders again. The x's for all inverse guys are going to be ratios. And the y's for all inverse guys are going to be angles. You put in ratios, you get out angles. And really quickly, just because you guys make me a little nervous sometimes, I have to do a quick reminder. Cosine inverse is not secant. And tangent inverse, what am I going to say? Is not cotangent. Good. Because to find cotangent, you have to divide. And to find secant, you have to divide. This is inverse. And inverse means back. This is inverse. And inverse means backwards. Now, I'm going to go ahead and do a tangent inverse one, and let's do a cosine inverse one. Let's do negative root 2 over 2. Okay. I said just a moment ago something about reviewing the cheater chart. I mean, we're talking about the unit circle, so I guess the cheater chart shouldn't totally surprise you. But for inverse trig, I guess my brain goes back and forth, especially for inverse tangent. I love when I learned a cheater chart with Luca 2 years ago. 3 years ago? 2 years ago. I love the cheater chart because it makes inverse tangent so much easier for me. So I'm going to really quickly do the cheater chart again. So a few of you might have made some mistakes on your Chapter 4A quest. Or maybe I'm thinking the Honors Precalc Kid 4 test. Either way, because they're all the way through Chapter 4. They're doing Chapter 5 before the end of the semester. Cheater chart. Some of you guys like it. How many of you guys remembered using it at some point in time? Like a third of you guys? A half to a third? Okay. We start at 0. Pi over 6, pi over 4, pi over 3, pi over 2. Who goes first in my cheater chart? Tangent goes last. Who goes first? Sine, and then cosine. Okay. Why am I making time to set it up? Because sometimes I go so fast, you're just like, blah, blah, blah. Thanks. Now I'm going to go quickly, but I was just reminding us of what the cheater chart does and how it does it. It gives us values of sine, cosine, and tangent in the first quadrant. Yeah? Because 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So how do they come about? You guys remember the song? 1, 2, 3. I do it every no? And when I'm doing it. Okay. 1, 2, 3. 3, 2, 1. All over 2. And awkwardly with square roots, and that's not a part of the song that Luca had. Square root of 3 over 3. 1 square root of 3. Wait! That's not right. Sine counts up. What am I missing? Who should be the first value? Counts up to 1. Cosine, 3, 2, 1, counts down from 1 to 0. Tangent is found, come on, quotient property, by dividing sine over cosine. Tangent is sine over cosine. Careful, 0 over 1 is 0. 1 over root 3 rationalizes to be square root of 3 over 3. This over this becomes 1. This over this becomes square root of 3 over 3. 1 square root of 3. Ah! What's 1 over 0? Undefined. And that's our cheater chart. Now, why do I like the cheater chart? All the values are right there. So I can go from there back to the angles like tangent inverse of -1. Square root of 3 over 3, 1, pi over 6, pi over 4, pi over 3. Pi over 4, tangent's a 1. Wait a minute, I don't want 1, I want -1. We'll use pi over 4. Come over here, come over here, come over here. Tangent, pi over 4. I don't want first quadrant, I want fourth quadrant. Well, don't go up pi over 4, then go down. Oh, easy, -pi over 4. Oh, exactly. Whoever was singing, I don't know who was singing. Cosine inverse of -√2 over 2. Aw, stink. 1, 2, 3, 3, 2. Oh, 2. Oh, that always happens in the middle. That's right. Sine and cosine are both √2 over 2 at pi over 4. Pi over 4. Oh, it's a negative. Okay. Not pi over 4. Not -pi over 4. I need to go, who's this pi over 4? I need to go second quadrant pi over 4. I'm supposed to be looking only here. It's not the positive one. Must be over here. How much of a calzone? 3/4. Not 1 pi over 4, not 2 pi over 4, but 3 pi over 4. Dun, 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 dun. What if I was to be super crazy, and before having you go to your calculators and make sure you know how to do second tan and second cosine, which I think you can do, what if I was to ask you something super of square root of 3? Oh, stink, it's sine over cosine, which means I must have √3 over 2 over 1/2. Wait, square root of 3 over 3, 1 square root of 3. Oh, it's the last one, pi over 3. And it's a positive, so I can keep the first quadrant. I I like the cheater chart. But the problem is, did you guys realize I didn't just access the cheater chart for those answers? This one I did. Cheater chart was enough. Square root of 3 over 3, 1 square root of 3. In my head, boom, boom, done. But neither of these came straight from the cheater chart. What did I have to think about? The sign. The positive or the negative. The sign, the positive or the negative. Because the sign, this one, tangent being a negative, this one, cosine being a negative, I couldn't just steal from the first quadrant, because what is everybody in the first quadrant? All are positive. So stink, look at that, sneak, sneak, sneak. He knows the pain, he was in here last year. Negatives, not first quadrant. Oh, so then what did I have to do? Highlighters, do you have them out? I had to come over and ask about or reference for tangent inverse. Where am I allowed to look? So I had to think of sign. Cheater chart gave me which type of angle. Is it a pi over 6, a pi over 4, a pi over 3, a pi over 2, a 0? Is it on the x-axis, the y-axis, one of the three in-betweeners? Cheater chart gave me what to put in the denominator. Cheater chart did not help me with the negatives, which quadrant, because I don't just have to think which quadrant, I have to think specifically which legal quadrant for tangent inverse and which legal quadrant for inverse cosine or for cosine inverse. Does cheater chart help? Yes. Does it do all the work for you? No. Because you have to think if it's a negative, oh, stink. Okay, so take what I know, aka take tangent is 1 at pi over 4. Take that. Think about, okay, so tangent inverse, I have to go fourth quadrant negative. Oh, negative pi over 4, haha. Cosine negative, aw, stink. I know it's a pi over 4, but I don't want the first quadrant, I want the second quadrant. Okay, fine, 3 pi over 4. Whew. Now guys, approximate values, no stress. Hit the second cosine button. Yeah, there you go. How about the second tangent button? Are you allowed to do degrees or radians? Perfect. Let's go on to something that's a little bit more important for homework. What if I was to this is what I want. This page. What do you guys think then you would do with arc or inverse cotangent? Second sine, easy. Second cosine, easy. Second tangent, easy. How do you do arc cotangent? Or arc cosecant? Or arc secant? Oh yeah, 1 over. Nope, you're wrong. Oh. But we always do 1 over. I mean, yeah, we do 1 over. We do 1 over when we're dealing with solving focus for focus ratios. It's like chapel all over. Focus. Okay, ratios. When you're solving for ratios, yeah, you flip it. But here's the problem. When you're doing inverse, you're not solving for ratios. What are you solving for? Angles. So you sine inverse, but I say, no, I need sine inverse. I need the angle from the reciprocal inside. For secant inverse, I need cosine inverse, but of the reciprocal inside. And for cotangent inverse, I need tangent inverse for the reciprocal of the inside. So down here, when they ask for arc cotangent, I'm going to use tangent inverse of the reciprocal ratio. I know it's weird. I know it's tricky, which is why I'm having you write it down. I know it's tricky, which is why I'm having you write it down. There's one concept we didn't go over. I know it's 2 pages of notes. It was really just one concept. So get as far as you can. I'm going to extend the Google Classroom deadline to Wednesday, but work on your corrections tonight as well. Get as far as you can. Google Classroom extension is until Wednesday. But we are going into 4.8 tomorrow also because we just have one quick concept to cover. So come with any questions you have on homework. We might be able to cover a couple of them tomorrow, even though it won't be turned in until Wednesday. Bye, guys. Ayman. Oh, there you go. No.